Yeah, Daljit.
Okay, so after this class, please do not forget to mark your attendance sheet, and please just have a look that it works, because I just created that sheet. So please see if it works for you, and you can always edit your answers. I'll be asking some questions based on every class that I take, and you need to answer those questions. So if you answer it correctly, the questions will come after the class, and if you answer it correctly, I understand that you have attended the training.
Okay.
Okay, so I start by sharing my window. I'm just preparing myself. This was, I will start from where I left yesterday. Our example was a complex web application which involves some proxy, some web front, then again some proxy, and then, means web front was talking to web API using some proxies. For now, to make things simple, I will remove the proxies and I will have just two components. One is my web front and web API, which will talk to each other. So try to understand what is the approach I am taking, the pedagogy approach that I am taking to take this training. There are two approaches to understanding a system. One thing is that, okay, if I have a system, let us say Docker, I take it as a black box and I see how it externally behaves. This is called a top-down approach. I look at the system externally. So what yesterday I did was, and what today I'll do a little bit, is that we'll take a top-down approach of seeing how two containers behave with each other. Like, we will take container as a black box for now. We'll understand that it is a mini computer running on your main computer. And then we will discuss how it is different from virtual machines. But for now, let us say we do not understand its technology. We understand that it's just a computer. It's just a small. What does a computer have? It has a RAM, it has processor, it has hard disk, and it has network. So these are the four essential things of a computer. So we can attach volume to a container, and I'll show you how to do it. We can remove volume, and we can attach RAM and give it more RAM or less RAM, but it's an advanced topic. So I'll just tell you theoretically, I will not do it here in this session, because it won't be required much until you become an expert. So how many cores you add, like there are 4 cores, or you just want to give it a 1 core, or you want to increase RAM in one of the containers. Okay, that is an advanced topic, but of course you can do it. But what are the simpler topics is that, okay, let us understand that my container has a fixed amount of RAM and a fixed amount of uh, a processor. What differences, what computation computer can do is it can either compute a process by taking an input it can take either from the network or read from a file. Output, a computer, a processor, suppose it does not have a monitor, then or a sound card, that the only output it can do is that either it can print to file, or it can print to a logical volume, which is like your hard disk, or it can print right to network. So these are the two outputs we are interested. A container should either write to a network. In our case, Webfront and Web API are writing to network. If they are not writing to network, they are writing to a file, and then we will read the file as an output of a process. For example, you do a multiplication and you write the result either on a file, or you write on a network, or you write on an input output, standard input output device. So I am not interested much in standard input output because containers are run on the server. So the only way is you send some, say I want to multiply two numbers, I send a network request as an HTTP and I get response as HTTP. Okay. So we will take a simpler example now and see, and then after taking a simpler example, we will go to the like a bottom up approach. Like we'll see from inside what Docker is. But first you will see from outside what Docker is. Does that make sense? Okay. So I see very few people today. Almost like only my team. Anyone from Chennai is here? The team that was developing using Docker Compose? Okay.
Yeah, Jadit, we are using currently Docker.
Yeah, but very few people. Like I was expecting around 20 people, 20 plus people from your team, right? People are entertaining. They are not interested. They're having some problem.
Yeah, maybe they will.
Do you have any idea?
Yes, but within 2 to 3 minutes, they will. Remaining people will.
Okay, remaining people will join in 2 to 3 minutes. Okay. 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 Let's see. Should I wait for them or should I go further?
I think we should start.
Okay. See, I have a compose file. Okay, let's start by writing a compose file. Okay. I had it something already written, but I'm not getting it where I wrote it.
So, Daljit, Tanuj here.
Yeah.
So, like, I can understand like Docker Compose is a complex file if we compare from a Docker file, simple Docker file.
Yeah.
So, like, what all functions Docker Compose perform? Like, for a Docker file, we'll be running a Docker file, building a Docker file, right?
Let us see. Let us see. Let me open first, and then we will discuss what function it performs.
Okay.
Good. So this is my Docker Compose file. For example, okay. See, theoretically answering questions and doing some practical, I will prefer the practical approach. This is my simplest Docker file. I can make it more simple by removing webfront. So I'll do it also. Don't worry. Okay. So in a way, for example, I'll simplify it more. Right now I have two components in my Docker Compose file. This represents a Docker, this represents a Docker. And since it is a Docker Compose, is used for server-side programming, this also creates a service on top of Docker. This image creates a service which I call it Web API here. I can call Web API 1.2 also, not a problem. I can call it anything, but for now I'm calling it Web API. Okay, and this is web front. Web means like I have a front end and I have a back end. Okay. This Web API, the logic goes is that in this, what happens is that I'll show you the program. What happens? Let me show you. My front end. This is my front end. It reads the environment variable backend URL, which I passed from Docker Compose file. And then it makes a request to that URL. And then it tells me that welcome. Front end is running on socket.getHostname means, and the back end is running on so it gets its resource. Sorry, I think you may not be able to see it completely, so I'll break down the function. If I can change the font or something so that you can see the whole thing. Yeah. So I think now you can see the complete file. Please try to read it. It's what I'm just printing is for debug. I'm printing the URL and printing the output of the resource here, and I'm printing the front end's host name. That's all I'm doing here. Very simple. Some information from some front end and some information from back end. That's all. And what is the back end? Back end is a very simple file. This is back end. What I'm doing in the Docker file is I wanted to come back later, but I'm simply copying. I'm taking a Docker file. I'll explain all these things, what they are. But basic operation is I'm copying from the host when I'm creating a Docker file, when I'm creating a computer, what I am basically when I'm creating a container machine or something akin to virtual machine, or something akin to a computer. I'm copying something from my host to the machine. I'm creating a work directory and I'm copying my app.py here. And then I'm saying that when I run this Docker, basically entry point and CMD means that it actually means that when I run this container, run this Python file. That's what I'm saying. Please try to have a look and absorb it. Pip install Flask. Flask is the library required for running any web application on Python. And Python Alpine is a distribution or the image, a base image. This is what we call as a base image. Now, what is base image? I'll explain later, but try to have some idea of what it is. Okay. So I wanted you to just have some idea. Now compose, actually you understand it correctly. Compose means composing any application. The basic advantage of microservices, I should be able to break it up into a compose application is basically composed of two or more. Of course, I can run a compose with one application also, but the basic idea is two or more. Yeah. So that is Docker Compose. So I run this. This is my terminal. Go to the right directory where my compose file is. It is cd compose. I make sure that this is the Docker Compose I'm referring to, which is vim docker. Saying I'm running it at two places. So I'm just closing this. Did I make any change? Don't want to make any change. This for this program is Visual Studio Code. Yes, this is the program I'm referring here. Same file. So Tanuja, try to understand what Docker Compose is doing here. It is enabling me to run, like I'll show you running Docker Compose up. It is enabling me to run two containers simultaneously and connecting them with a bridge. I have not mentioned network here, but when two or more containers run, they need to talk to each other. So all the containers run in a compose file by default run on a bridge, and the name of the bridge is the name of the directory in which I'm running. For example, I'm running it in directory compose. So my two, it's saying attaching to compose web API 1 and compose web front 1. Okay, let us see. These are the names of the containers that it created. Let's see what has happened by this. I'll create a new terminal. Okay, I can always shift here to container terminals. And I have a debug console and output and problems. So you can see all this source code is online. I've checked in. So can some of you along with me try it also? Docker Compose PS. Oh, I'm not in the right directory. So to run any Docker Compose file, you need to be in the default directory where a Docker Compose file is there, or you have to mention it using some flag that this is the Docker Compose I'm referring to. So now Docker Compose PS will show. So it is showing me that two containers are running, and one is running on localhost. It's port binding, port forwarding is a concept in any networking. You can just, maybe you don't understand what I'm trying to say. So you can always search on things. So what is port forwarding? You can always search port forwarding or port forwarding explained or what it is used for, So you can forward ports from one machine to another. Similarly, in an internal network also, you can forward one port. Like you can use an external IP address to forward for external communications and forward that traffic to an internal IP address. So this is what is port forwarding. So I am using port forwarding here. I can refer the machine by the IP also, and which I'll also try to show you. The localhost 8000, the 8000 port is being forwarded to front end, web front. It's not working. Maybe I am forwarding to some other port. Let me see which port I'm forwarding. I'm forwarding to 5000. Welcome. Front end is running on this machine. Back end responses. Back end is running on this machine. Let us now try to understand this example. Okay. And I would advise that you run it. I can give you the code, but no one is asking me where is the URL. Give it to us. So I don't know why. Anyone interested to run it?
Yes, we are interested to know.
You are done.
But
great. So I'll give you the URL. This is the URL. And once you clone this project, the git status, the branch I'm using is branch name is envoy. You will not get this code on master branch. You will get it on after you get that code, after you cloning that code, after cloning, do git checkout envoy. You will get this code locally. Let's try to understand what's happening here. By the name of directory, there are many networks here. You don't have to get confused. The name of my network will be compose because my directory name is compose. Okay, so if my directory name was envoy, it would have been envoy default. Another directory, if I go and I create a Docker compose and run it, it will be this network because this is the network directory name that matches it. For me, for now, this is compose default. The type of the network is bridge. The driver is bridge. What is a bridge driver? I'll explain you. There are two kinds of driver. Bridge is the default, and overlay, when I'm using multiple computers, Docker, I create a cluster out of Dockers on multiple computers, then it is called overlay. The driver is overlay, and none means you understand that. And there are third-party plugin drivers, which are advanced topic, which we do not need to discuss in the basic class. So what is clear with bridge and overlay? There is also a driver called Mac VLAN, which is like if we are running some legacy program which does not understand bridge network. then this driver, then we use Mac VLAN. Basically, it emulates a machine by having a virtual IP, by having a virtual MAC address. So that driver we don't normally use because it does not that efficient. It is called Mac VLAN. Mac VLAN means, if you don't understand what I'm saying, it's like this, Mac VLAN. So when I do Docker network, no such object. Why? Sorry. It was Docker network inspect. I forget sometimes commands. So if we have to inspect the default, like if I run a Docker default, it gets attached to a network named bridge, and this network name also has driver bridge. Okay. So right now this does not have any containers because I'm not running anything without on the default space, like without compose. Okay. Where I am running is I want to inspect this. So what I write, what did I mistake I made? Compose default. Okay. Spelling mistake, these are very common mistakes that people do. So not to make the mistake, I'll double click here and then do a right click, do a central click. Okay. So now I see I have two containers in this network. Try to understand this concept, please. Then I'll continue. Okay. So anyone trying what I'm trying to do? Anyone is having any problems? So except Tanuj and Deepmala who are from the CTL team, others please, like all others, anyone else from CTL?
Hello.
Yeah. Tanuj, you are from CTL, right?
That is Samadhi
Soumya.
side. Yeah.
Yes.
Soumya.
Yes.
Okay. Anyone else from CTL?
Yeah, Sandeep Sen.
Sandeep. Okay. Anyone trying this Docker example?
Yeah, Dalit, you are currently running on Visual Studio, right? that Docker.
Yes, Visual Studio. It doesn't matter. It's like you can use it command line.
But-
Does not matter which what you use for editing. It's just an editing program.
Whatever you said, those files are enough, or you have to add some more.
No, all files are there. You don't have to add anything. You just have to go to the compose directory, and then you can run it using Docker Compose up.
Yeah, okay. Thank you, Jaldi.
Yeah, it works. Does it work? Okay,
We are
let's
trying now.
Yeah, try. No issue. I'm waiting. Okay, for the rest of things, just to try to understand the concept, and then I'll give you a time. I'll give you a break to do it. Two containers are running. Each has its own IP. This is my backend, which is called Web API. It has an IP address, and the front end also has an IP address. The backend has an IP address. I can open it directly. It's running on port 5000, which is default port for Python Flask applications. So if I hit my port, which is my backend, it says welcome. Python is running on this hostname. Yeah, it's called D11 something like that. Let's check it. So this is the hostname D11. This is the long name. It is short. Why? When I try to do curl localhost, not localhost, this IP on the port 5000, I get Python is running on hostname 163. Yeah, this is the thing it is printing. It has an endpoint address, it has a MAC address, it has an IP4 address. And the other container is this container. When I hit, which is 172.21.0.3, it tries to hit this, and then it gets the response here, and then prints it back to the browser. I try to shoot through. Instead of 2, I write 3. The IP from here. So it says front end is running on 9F4F, which is the host name here. 9F4F. This is a container ID of the Docker container. Okay, so these two containers together make up a Compose application. Okay, it says front end is running on this, but back end is running on D110S7E, and what is the backend URL it is trying to hit? The front end is given some URL dynamically. How does, I have never coded in the backend that you hit this URL, but it is doing it. How it is doing it? Let us try to understand that. Okay, boss, if you're trying it, do try. I'll make a cup of tea for me. It will be easy for me also. Otherwise, I should go forward. Tell me how I should do it.
Are you serious? You're going to
I'm serious,
prepare
boss.
tea?
I'm serious. I'm a human being. I cannot speak for 1 hour continuously. I'm pretty serious. I'm pretty serious on things.
I think grabbing a cup of water will be fine.
Okay. Yeah. Something like that, yeah. I cannot know, see, like we used to make fun of our teachers when I was in school. But I know it's very difficult to continue speaking for 1 hour. The tongue starts paining. I keep a glass of water with me when I'm speaking.
Exactly.
Yeah. I do code for a living. I do write configurations for a living, but speaking continuously, it's not. It's like you know. So let's see what to do next. So what I'm trying to understand is how does the backend know what URL to hit? That is the next challenge I want to understand. And also change it dynamically. So what I'll do is Docker compose exec, Docker compose ls, sorry, Docker compose ps. Then I have two applications running. One is web front and one is web API. I say Docker exec means execute a program on web front. And what program I want to execute? I want to just execute sh. Sh is a shell script. It's like a shell, bash shell. It says no web front. Okay, because I did not enter the command correctly. I was wanting to do it because if I do, I can do the same command with Docker, but then I'll have to write the Docker ID here. But I want to refer the container with the name. So Docker compose exe web front sh. It took me to the shell of the web front. Now in the web front, what happens is that we have the concept of services. We have two services running, and this, what I write here is a service name, and inside this service, this application is running. So I can do curl web API. So I want to hit the service and the container that is running inside the service. My services are web API, and inside the web API, this container, this image, a container is created which has this image. That's as simple as this. Service name, container name. I am hitting the service at the port 5000. You got it? Or you do not get it? See, either you get it or you do not get it. Deepmala, do you understand it?
Yeah, Daljit.
Great. Any questions? Soumya?
Not yet, Daljit.
No, Soumya, I'm asking Soumya.
Hello? No,
Yeah,
no.
Soumya, questions?
Still I have no questions.
So you understand everything?
Not everything, but
Okay,
if
something.
I have a question, I'll ask. Okay.
Okay. Another person, who is this next? Anuja, you understand it?
Yeah, Diljit. Yeah.
Great. And another person was from Sandeep. Sandeep, you understand?
Yes.
Okay. So Shiva, any questions? So once you understand, we will go to scaling of the backend. Suppose there is a lot of traffic and we need more computers in a way. The same compose file we can run on a swarm, which is called Docker swarm, and which is run on say 5 or 10 computers I take and make a cluster. Right now I don't have 5 or 10 computers, but even on a single machine I can say the command I can use, go to a command. I can say docker compose scale. I am saying web API run at least 3 instances of web API. Does that make sense?
Yes.
Okay. So I enter it. You try to see the output and read what's happening. Okay. So if I do now docker compose ps, what do I see? I see there are 3 instances of web API and one instance of website. Okay. So what will happen now when I do an ls, when I do a curl, which instance it will go to? 1, 2, 3. Any guesses? Come back to my previous terminal. Now if I do curl, which instance? There are 3 instances running. Now which instance the response will come from? Please make a guess.
Web API 2.
What is your response?
That from second.
One? Second, a first, or third?
I think first.
Second.
So how many people say first? How many people say second? Okay, some people are saying first.
One people second.
1 person. Okay. Let us now do the experiment. It is saying B380. Note down. Let us do docker compose. Let us open another. How many networks I have is docker inspect. Docker peaceful. So now the response came from second, right? So someone who said second, I think is very intelligent. Okay. So the response did not come from 3, and response also did not come from API 1. So why did you say second, whosoever said? What logic?
Yeah, this is. Yeah. Earlier it was compiled first, right? Now it will go to the second.
Okay.
Am I correct?
Okay, and if I do it again, then from where response will come?
From third.
Okay, let's see. It is coming from second again. I think B380. Ideally, it should come from third. You're right. Webfront 3 is C9, and web app, and 1 is D11, and B is this, and the third is this. But let us do it from some more time. It's now from the third. It is now again from the third. It's now from the. So it is doing some kind of, now it is second, it is doing some kind of load balancing on the three pods. But exactly, I'm not sure of which algorithm it is following by default. We can control it, of course, through some advanced means. And when we do actually production side production load, we actually control it. But for now, some kind of load balancing is happening, because I can at least say that it is, if it is not doing round robin, then at least it is doing random. That randomly out of the three, because there is no load, I know that on the three, everyone is fully on rest. So it is picking up some random node and returning response. So it is doing randomly. It's not that it's happening. So when we use Kubernetes, etc., we can actually control, when we are using a service mesh, we can actually do a fine-grained control. And Kubernetes also does a better control rather than just Docker. So some load balancing is happening. Okay. So this was a concept of load balancing. And running a basic compose application. Now we will do something more advanced. What happens if I say welcome, or instead of welcome I write good morning? And then I restart the application. So if I restart the application, will it change? It will not change. What do you guess? Okay, I'll tell you.
It will not change.
It will not change.
Yes.
Yeah, it will not change, because the in the Docker compose file, I'm referring to some static images. I'm not doing anything dynamic. The app, the Docker was created before I made the change. The Docker image was created before I made the change. So I will go to this Docker image later. But what I can do in the Docker compose is that I can copy the change, instead of copying, I can something called volumes. I can open a volume. I can share a volume from the host to the image. So where did I make the change? I make the change in web app. So what I will do is, the syntax for just a minute. concept I'm trying to do is a volume in I had actually written of this from the previously, but I don't know where I lost that file. Anyways, leave it for now. Volumes I'll take tomorrow. I had written an example for a very good example for volume, so I'll take it tomorrow. Today I can just take some basics of creating the basic Docker file. I'll shut down this example. So I have changed this to good morning. What I'll do is I'll build this file. To build this Docker file, what I need to do is I go to the web app. I have two files here, the application file and a Docker file. Alpine is a distribution, a very lightweight distribution of Linux. I could have written Ubuntu here, which would have made a base image from Ubuntu. I could have written here CentOS, and that would have made a CentOS image. And what images I'm taking, basically the images should be present on Docker Hub. Means it's downloading an image from Docker Hub. It's not that I'm writing something randomly here. For example, if I go to I need a base Python image. So I write Python. So it has 500 million plus downloads. To pull up a Docker Python image, it is like this is the command docker pull Python. I could have just used okay. So I'll tell you what I'm trying to say from here. Docker search Python. So these are the Python images I found on Docker Hub. Okay. Like this is the CentOS Python image. Okay. So I can also have my own Python image put on Docker Hub. That is another thing. But right now I'm using Alpine distribution of Python. So, it has searched for Alpine distributions of Python, and Not sure why this result has not come, the base image, but the images, it has searched for the images based on Python Alpine. So to build this image, what it is doing, what I do is, the command is docker build. I want to give it a name. Name I give it on basis of tag. I want to say tutorial1. And from where? Current directory. So dot means the Docker file. The default Docker file is Docker file, called Docker file. If I have customized, I can write the complete name. But the default name is Docker file, so it will try to. Okay, was not successful. Why? Because it build only takes one value, and if I have to tag, I can write it here. Let me see. Sometimes I make some syntax mistakes. Let's see what is it. So basically, I build it like this: Docker build dot. Okay, it has successfully built this. And how do I see it? Use it, Docker ls. I will give it a name using tag. So right now I have not tagged it. That is why it's called none. And it is 4A 43 BED 6FL1D. So this is the Docker ID which I have just built right now 20 seconds ago. And how to run it? I copy it and I say Docker run as daemon in a detached mode. I normally forget commands, you know. So thank God it ran. Because I don't remember commands. I just check it whenever I need it. I learn concepts and then I create commands out of those concepts. So the commands actually verify that my conceptual understanding is correct. So please don't confuse with image ID and container ID. Image is like your class, and if you have done classes in objects programming, object-oriented programming, image is like a class, and from that class an object is created. Okay. So image is like a factory. It's like a factory model. It's a model of what has to be created. And if I make any changes here in the container, the class doesn't change. Class can create multiple, you can say, objects. Now I'm running a container. Now I want to see what IP it is. The default I told you is bridge network. Docker. What today I've done is now building up from the ground up, you know, the bottom up approach, you know, not the top down approach which we were taking previously. Now the bottom up approach is write a Python file, write a Python file and build a container out of it. And tomorrow we will do tagging of it. Okay. Tagging means giving it a name and then pushing it to the repository. So the first thing is you write a program. Then from the Python program, you create an image. From the image, you run that image and create a container. After you have the container, do network inspect bridge. Means the default network. So this is the container it had created. If you check the ID, okay, it has by default given it a name. So container will by default get a name. If I don't give it, the Docker daemon gives it a fancy name like even Epic. And two containers cannot have the same name on a host unless I delete that previous container. Okay, so IP address is 172. I copy it. And then I know that Docker is running on port 5000. Okay. So it has good morning, Python is running. So my change is applied. So this is about building a Docker container. First an image and then a container. Any questions on building a container? And one more interesting thing I want to share you. Uname-R. Uname-R basically gives me the kernel, the version of the kernel. Okay. Every other application I might have different on the container. Like I can have a different version of GCC or Java running in the container. But since a container shares the kernel of the host, the kernel version will remain the same. That is what I want to say is Docker exe cit. The Docker host is this. So I'm saying run a terminal interactively on Docker host. This is the Docker host which is running this command. Here also if I do uname-r, it will be 5.3.04, which will be the same as my hostname kernel because it does not have its own kernel. A container behaves like an operating system, behaves like an OS, behaves like a machine as an independent machine, but it does not have its own kernel. It shares the kernel of the host operating system. This is the most important difference between a Docker and a virtual machine. A virtual machine is like something which you use for VMware or VirtualBox. Or a KVM, type 1 hypervisor. There is a KVM, but the most popular one people have heard is VMware and VirtualBox. Okay, guys. Any questions? Okay. Anyone is awake?
Yeah, Daljit.
Okay, great. So when I am on this container, what I can do is wget localhost, check what is running. It is indeed running on this local here. I'm inside the container. It got the file and saved it in index, and it says good morning, Python is running on hostname. So this was the basics of today. We took up the bottom-up approach, like trying to see for what Docker is from inside. And we took up a Python file. We created a Docker file out of it. And after the image was built up, we ran a container, and now we are inside that container. And we see that the kernel version is the same inside the container as well as outside, because conceptually, if we read the documents of Docker, Docker shares the kernel of the host. And that was all for today. It was excellent talking to you all. And tomorrow we will discuss tagging and volume mounts inside Docker. I have already shared the attendance sheet, and let me see if though for those who have joined late, the attendance sheet was this. Yeah. I'm sharing it again. I'm stopping the recording.